All right, with that, thank you, everyone. We will now turn it over to the applicant, the applicant's engineer for a presentation. You have on your flip chart what you're going to have up here? Okay, great, thank you. And introduce yourself for the record. Thank you.
Thank you. Can you hear me? Not close enough? This better? Thank you. My name is George Andrews. I'm with Loureiro Engineering Associates. We're out of Plainville, Connecticut. I'm a professional engineer. Been in the business since 1986, and I specialize in solid waste application design as well as permitting. And I'm very pleased to be in front of you tonight to be representing Shoreline Rail and Recycling, LLC. Just run through the agenda very quickly. What I wanted to do is start with a little background on the site itself, where it's located, a little information on the existing conditions, and then transition into the proposed activities, and then discuss the soil erosion and sedimentation controls that are proposed during construction, and then close out with some of the alternatives that we evaluated as part of the process. And in light of the reading of the DTC package, I did provide a response to that, so I'd like to just glean over some of our response comments to the questions that were asked. Transition to our existing conditions. Everyone is aware, this is the rail line right here. There's a rail spur that actually services this site right through this area here. This is Old Post Road 145. So I'll transition into the existing conditions map. You get that quickly, someone here. So I'm sorry, I'll be pointing in both places so that everyone can identify. The site's located at 30 Old Post Road. Excuse me. The total site is 11.2 acres. It's in zone I2, which is an industrial zone. This site formerly housed the Unilever distribution warehouse. The former building, as indicated earlier, was 186,000 square feet. And I'll just outline that building. I know this slide is a little bit light, but the building, pre-existing building, was located right there. There's our rail spur, and then there's the Amtrak line. So February 8, February 9, 2013, we had a significant snow event, and the roof collapsed on the building. The demolition was immediately actuated by this owner, and the building was removed. So at this point, for those who haven't been to the site, it's essentially a 186,000 square foot concrete slab. There's wetlands present on the site, right up here to the north. That's an existing wetland, and that actually drains down through some drainage structures and then feeds into a swale that runs right along the railroad ballast. So it's essentially accumulated a fairly significant amount of sediment at this point. But that particular swale has been identified by our soil scientists as a wetland, as well as this area here. There's also one small pocket right here. The areas that I was referring to for those up on the stage, we have wetlands right here. This is where the swale runs. And then this is the northern wetland. So the wetlands were flagged by soil resource consultants. That's David Lord, certified soil scientist. And the site is also located within the coastal boundary. It's also located within the FEMA coastal flood hazard area. It's a zone AE, and that AE elevation is elevation 12. So the slab that we have, the existing slab, is elevation 9, and the flood elevation, the 100-year flood elevation across certainly this part of the site is elevation 12. The primary access to the site is from Route 145. There's an access road that comes down. This is fairly steep in this area, so you can see they kind of swaged the access drive down to the lower parking area. Of course, we have two parking areas, one in this location, one in this location. And the access, once again, for those on the stage, located right here, kind of S's down to the lower parking area. The site utilities, the site has water service, and it also has an existing subsurface sewage disposal system. Water service comes in from 145 and actually connects all the way back through the industrial subdivision here. So it actually runs through the site and it can be serviced from both directions. It was a very robust fire protection system in this building as it warehoused a variety of different products that were flammable. The subsurface sewage disposal system, the septic tank is located right here, and the leaching field is located right here. And once again, for those on the stage, the leaching field is located right in this area, and the septic tank is down near the building. I think that gives a fair background on the existing conditions of the site. I want to transition now into what we're proposing. So this is our site plan. As I mentioned, we have an existing slab that's 186,000 square feet, runs right through this area. We're proposing a 94,500 square foot building built upon that slab. So it's a subset, essentially, of the overall slab. That's the building, and for those, let me flip that. This is the proposed building, and this is the existing slab. So the proposed building is equipped essentially with open access, both to the north and to the south. To the north, we would have vehicles actually entering the building, tipping on the tipping floor and such, and then load out from this building would be into the rail cars to the south. We're proposing an aggregate and milling storage area upon the slab, right over in this area. Once again, that's right over here next to the building. On the existing slab, there's a knee wall that essentially encompasses the entirety of the slab. Runs the full, with the exception of the areas where loading was previously performed, right here and right here. So once again, we have a knee wall that runs that full gamut. This storage area, what we're proposing to store there is aggregate materials, so it would be sand and gravel, asphalt millings from roadway projects, etc. There will be no solid waste from a construction and demolition debris perspective, and I'll get into a little description on what we're actually receiving and processing here, but that material is all going to be stored indoors. None of that will be stored outdoors in this stockpile. So that's just aggregate and asphalt materials. We've got a couple of scales that we're proposing. We've got an inbound scale, so trucks would enter the site and they would be scaled in right here. This is where the scales are, so they'd be scaled in. Then they would enter the building. Those that are dropping construction and demolition debris, they would drop their load within the building, and then they would run back down the ramp and get scaled on the way out. Truck routing, as I mentioned, would essentially bring them in, run through this building, and there's two tipping floors that we're proposing in here. All tipping and discharge of construction and demolition materials would be done within the building itself. None of that would be done outdoors anywhere. And we believe this is the first transfer station that actually would be fully indoors. Loads of sand and gravel and such, we have a separate access over here. Those vehicles would similarly be scaled in. They'd come in, drop the load, and then they'd be scaled out. I think it's appropriate to, with regard to some of the concerns related to the materials that we're going to have on the site, oh boy. Hey, look at that. With the materials that we're going to be storing in here, there's been concern. One of the comments that DTC presented was a concern related to potential flood contact with the material. Obviously, stormwater contact would be non-existent since all that material will be within the building structure. But I'd like to just go through the process so that we can all understand the types of materials that we're receiving there, what the process is that we're doing inside, and then what goes out, what stays, and what goes where. So the facility is going to be receiving construction and demolition debris. And for anyone not familiar with that, that would be, for example, this high school. Once this becomes aged and it is destined for demolition and reconstruction, all the materials that you see in here would be stripped, the building would be demolished, there'd be brick, wood, variety of different materials, insulation, carpeting, all of which essentially, some of which gets sorted on the job sites, some of it not so well sorted. But that material ends up getting delivered to this facility, and then it gets sorted on the tipping floor. And the intent of that sorting process is essentially to recycle as much of the material as one possibly can. The material, the final construction and demolition material after stripping out all recoverables, for example, glass, plastics, different types of metals, etc., that can be recovered and recycled, the actual C&D material would get loaded onto rail cars and transported out of Connecticut, typically to Ohio, which is where the majority of Connecticut's construction and demolition material ends up. The other materials that are stripped out are actually stored in the building, and those materials may be rail loaded and recycled, or they may leave the building in roll-offs. So they may leave in a truck and be delivered to a facility that does metals recycling, etc. Just wanted to present a quick case with regard to the criticality of the site. And this comes back again during our alternatives evaluation. The intent of this particular project with the processing that we have here is to be able to utilize and fully utilize the benefit of the rail system. So that rail spur is really integral to the business model that's been prepared for this application. Other applications that don't have access to that, they truck the material in, they have to truck it off. And our intent was to limit the number of vehicles that needed to run the I-95 corridor. And we're able to achieve that by utilizing that rail spur for the majority of the materials that will be disposed of. I'd like to just talk quickly about the activities that are proposed within 100 feet of the wetlands. Initially, I'll talk about the activities themselves, typical construction activities, etc., and then I'd like to talk a little bit about the uses that we're proposing within 100 feet of the wetlands. And once again, I just skim the wetlands. We've got some along here, and we've got a wetland up here. So to kick things off, the construction of the scale, which is located down here, there's a considerable grade change from here to here, approximately 20 to 25 feet, I would say. This wetland being well above the scale house that is located down here. But the scales are proposed to be constructed, and they are just about 100 feet away from that wetland. Our stormwater collection systems, my associate Emily will be talking a little bit about the stormwater system, but we have some improvements that we're proposing along here, and we're proposing an improvement right there, as well as over in this location as well. So those activities would be as close as 5 feet. This is the closest that we're going to be to the wetland. That's 5 feet. And for those up on the stage, that's located right there. And that is a replacement of an existing culvert that runs underneath the rail spur. The building itself, construction of the building, we're about 15 feet, 14 to 15 feet at the closest location from this swale. Grading and asphalt removal. So we're adding a little bit of asphalt in this area for the ramp, as well as this area. And those two areas are shown right here and right here. So we needed to eliminate some asphalt so that we could either match or reduce the overall impervious area on the site. So what we did is we removed asphalt in this particular area, and we removed some asphalt there, and actually came up with a slight reduction in overall impervious surface on the site. So we made up for these two paved areas with the elimination of existing paving in these two spots. Pole-mounted light, we're proposing a lamp that would be over in the vicinity of the scale house. That is located about approximately 98 feet from that particular wetland. And we're also proposing a new sanitary sewer mentioned on our earlier slide, where the septic system, it's a little odd. Septic system is located right up in this area. We're proposing a new discharge that will run from this septic tank over to the existing pump station, which is located right here. So that'll be a new pipe. And to show you up on the stage, that'll be a new pipe that runs right to there. So that is approximately 99 feet from the wetlands. Site uses and activities that will be within 100 feet of the wetlands: scaling of trucks, stormwater discharges, loading of rail cars, solid waste processing, obviously within the building structure, aggregate storage over in this area, parking within the existing parking areas, right here and right here, and use of the septic system. The leaching field is actually within 100 feet of the wetlands, so the use of that leaching field would certainly be a use within 100 feet of the wetlands. With that said, I'd like to turn the microphone over to Emily Pearl, my associate, who has worked on the drainage. And the pointer is, well, you can use this.
Good evening, everyone. My name is Emily Pearl, and I'm a civil engineer with Loureiro Engineering. The site is comprised of two separate drainage areas. The first drainage area is located on the west side of the site, and stormwater from this area runs through a series of catch basins and stormwater pipes before ultimately discharging right here into the swale that runs adjacent to the Amtrak rail line. The second drainage area is located on the north and east portion of the site, over here and up here. And stormwater from this area also runs through a series of catch basins and stormwater pipes before ultimately discharging through a set of twin pipes into the drainage swale as well. This drainage swale was the drainage system, was evaluated, and a few improvements are proposed. We're proposing to make improvements to the existing system to help reduce the overall disturbance to the site. We're proposing to increase the pipe sizes running along the west side of the building here. That'll be adequately sized for a 25-year storm event. We're also proposing to install two hydrodynamic separators at both point source discharges on the site. So that would be right down here and over here. And the hydrodynamic separators were designed to treat almost 90% of all of the total suspended solids in the stormwater runoff. We're also coordinating with Amtrak on the restoration of this existing drainage swale. So this will help with stormwater conveyance on the site, as well as other areas surrounding the site that discharge into that drainage swale. As George mentioned, we are adding these 2 ramps, but we'll be replacing that impervious surface with 2 pervious surface areas. So we'll be decreasing the overall impervious coverage to the site, and we'll also be increasing flood storage by grading. We also submitted a stockpile stormwater management plan to the town, which will help prevent any solids from the aggregate stockpile area from entering the stormwater runoff. And that will include 2 rings of mulch stocks, which will encompass the pile. As George mentioned, there's also a knee wall that encompasses the majority of the concrete slab, and we'll place jersey barriers in any areas that there is no knee wall in place. Thank you, and I'll pass this back to George.
Thanks. Thank you, Emily. Next, I'd just like to talk about some of the flood concerns. Obviously, some of the town comments that we received, as well as the town's consultant, bring credence to having a discussion on this. So the site is actually located within the head of the drainage area. So we took a good close look at that and identified that the flood water that we can anticipate from this particular area will typically be backwater. So that flood area, once again, includes pretty much this area. And up here, the grade picks up considerably along the back and along the roadway here. So the stockpile is located on top of the slab, which is at elevation 9. As I mentioned earlier, the flood elevation in the area under the FEMA analysis is elevation 12. So that leaves 3 feet of inundation. So what we did with the aggregate storage area, and once again, I just want to reiterate, this is not construction and demolition debris. This is sand and gravel as well as asphalt. That material would be stockpiled there, and as Emily mentioned, it'll have a dual filter sock system that runs around that. And the filter socks that we're proposing have a outside jacket that endures for over 365 days. So it's a somewhat permanent system that's utilized. Those are filled with compost, and the compost is actually designed to adsorb and absorb materials that migrate from the stockpiled material, or these are also used on construction sites similarly. And it's very, very similar to a biofilter. You may be familiar and may have had applications in town where a consultant has proposed a biofilter for enhancing stormwater quality. This is essentially the same material. We're using the compost-filled mulch socks. We're running dual rows around the stockpile area, and that has been specifically designed to help enhance any runoff that comes off of that stockpile area. The building activities, as I mentioned earlier, the building to the north is open with doors, and there are a variety of doors in the south as well. And those are openings. They're not, we don't have doors that come down, they're doorway, open access all times. So the building is cold, and as I say, those are open, and during a flood condition that's specifically, excuse me, designed to accommodate flow through of the building itself. So we haven't tried to button the building up such that we keep the water out. The concern with that approach would have been the loss of flood storage. So we actually opted to actually allow the water to penetrate into the building. We have come up with a flood management plan that we submitted to the town, and I know your consultant will be reviewing that. As I mentioned, we have 2 tipping areas, and those areas will be where trucks and vehicles come in, drop the material, and it'll be processed within those tipping areas. So there'll be pickers in there, people that are actually picking and removing different recyclable materials. So our plan, as presented to the town, is to work those two areas down on forecast of a significant flood event, so that we would minimize the amount of material that's on the tipping floor during such event. We typically have anywhere from 7 to 10 days to forecast a significant event, certainly of a 100-year event. So we would propose to minimize the amount of material that would be on the tipping floor. The other material is in roll-off containers and in bins located and stored along the side. And we would relocate the equipment, the heavy equipment that's utilized inside the building, to an area right up here. There's a parking area right up here, and that is at approximately elevation 22. And just to show you where I'm referring, right into this area. So that's where the heavy equipment would be relocated to get it out of the slab area. So we obviously the material that's in here, if we have flow through, much of that material, for example, the wood, is a floatable. So the concern was, if we do get a significant flood event, would that material be transported out of the building and then deposited either into a wetland or somewhere else, either on the site or off the site? So we have, and we detail in our detail sheets, we actually have a fabric system that covers these doors, and it gets deployed when a significant flooding event is forecast. And generally what that consists of is Schedule 40 steel pipes that are located on both sides of each door, and it's a cable-supported steel mesh that runs across each one of those doors. It's a 1-inch mesh. So that mesh is designed essentially to retain the floatables within the building structure, within the building itself. The building utilities. Early on, we met with the Zoning Board of Appeals, and we were granted the ability to reconstruct on this slab at elevation 9. And we testified at that particular time that all of the building utilities would be located at elevation 13 or above, which is 1 foot above the flood stage. So any electrical components, etc., that we do have a mezzanine here. There'll be an office and a stairway going up to that office that's located right here. And all the utilities associated with the facility would essentially be elevation 13 or above. I'd like to transition now to a brief discussion on the soil erosion sedimentation controls that we're proposing during construction. Excuse me. So we're proposing, as I mentioned, some work in this area where we're removing asphalt. That area certainly will be protected with silt fence, etc. We're also proposing some grade changes. Since we built ramps here and here, we need to remove some soil from the site to compensate the flood storage. So where I'm adding material here, I need to subtract some material here. So we're proposing grading in this area. Obviously that would be protected with the silt fence. And we're proposing the reconstruction, essentially the replacement of this pipe right here. This is all paved parking in this area. We have the wetlands down here, so we're proposing a perimeter silt fence that would run right through this area. All of the existing catch basins throughout the site. So the majority of those catch basins are located right in this area here. And there are several that are located, one here, and then there's also an inlet over here. So that's right, right here and right here. So all of those catch basins would be protected with circumference protection systems. It may consist of hay bales or it may consist of mulch socks, similar to what we're proposing for the stockpile. We don't have a particular need for an anti-tracking pad The work that will be done will be completed. The only place we can see anyone getting into any soil with heavy equipment would be right here. That would be a dozer. And that would just be removing that material. Trucks that get loaded with that material would stay on the asphalt at all times. So none of the trucks that will be leaving will actually be entering into the disturbed areas. I wanted to transition next into some of the alternatives that we took a look at. So once again, I want to reinforce the importance of this site for this particular application and use. The rail spur is really critical to what we're proposing here. Secondly, I just want to note that we're not proposing any activities within any of the wetlands. We're close to the wetlands, 5 feet at the closest point, right here. But no activities are proposed within any of the wetlands on this site or adjacent to it. We took a look, really the only options that we had were utilizing a variety of the existing facilities, as I mentioned, the subsurface sewage disposal system, the existing drainage, etc. The only real alternative that we looked at from a site perspective was removal and replacement of the drainage system. And we felt that that disruption would cause more damage than utilizing the existing system. Now, the existing system had been fully silted in, all the catch basins, the pipes, etc. So we brought crews out, we jetted all of those pipes, vacuumed all the catch basins and such, so that we could provide an adequate evaluation of how the system would function. When we did that, as Emily mentioned, we came across one pipe that wasn't large enough, and that was located there. So we're proposing to improve that one section of pipe, and then we're adding water quality improvements with those two hydrodynamic separators before the discharge. So really the only alternative that we evaluated was the potential of replacing that existing drainage system. One other alternative I'd just like to brush by quickly would be the possibility of locating the building further from this wetland that runs along the train tracks. So that would be right along there. Pushing the building forward more. Obviously the difficulty with that is we lose our opportunity essentially for rail load out within the building. Our objective is to be able to load everything, drop everything on this tipping floor, process it, and load it into rail cars, all within the cover of the building. I'd just like to summarize and then just hit on just a high level on some of our response comments to the DTC memo that was read into the record. So in summary, Shoreline Rail and Recycling is proposing a 94,500 square foot building for processing and storage of demolition debris, construction and demolition debris. Proposing a 1,500 cubic yard aggregate and asphalt milling stockpile. We're proposing dual perimeter mulch socks for treatment of the stockpile area, and we prepared and submitted a stockpile stormwater management plan. Sorting of the demolition debris will be accomplished, as I mentioned, several times indoors, along with all related storage. The only storage associated with C&D materials is a small fenced-in area located right there. And I'll show you where that is for the stage, right here. It's a small fenced-in area, and the only thing that we're going to put in there is propane tanks. If a propane tank happens to come in with a load, it can't be stored indoors. So it goes into that fenced area. That's the only product that we'll be storing from a C&D perspective that would actually be outdoors. We're using the existing drainage system with improvements to improve the water quality with the hydrodynamic separators, and we're using the existing subsurface sewage disposal system. We're actually reducing the overall impervious value to the site. As I mentioned, we're doing some compensatory removal of asphalt and we're adding a little bit. We're actually removing more than we're adding, so we're actually reducing the impervious area of the site. We're increasing the overall flood storage of the site. Similarly, I mentioned that we have a couple of ramps that we're constructing, and we're performing some compensatory excavation in this area, which is actually an increase in available flood storage. Once again, there's no activities proposed within the wetlands for this project, and we are implementing adequate site improvements and controls to actually improve the stormwater quality that gets discharged once the site is completely built out. Last 4 items is just to discuss quickly our response. I don't want to, it's, I believe, an 8-page memo. I'll just go very briefly with our response to the DTC comments. As I mentioned, with regard to the stockpile, I got into some details during my presentation of the dual filter sock system and the similarity between that filtration and the filtration of a biofilter, which was recommended in the memo. So I think we're providing the same level of treatment, just using a different approach, same product. I believe that there was a misunderstanding that construction and demolition debris would actually be stored in the stockpile area. I think I've hit it enough times tonight and indicated that all construction and demolition debris will be stored and processed within the building. So the only thing stored outdoors is aggregate and asphalt. With regard to the concern related to the FEMA flood elevation, we're very comfortable with the flood management plan that we developed and presented, and the barriers that we're providing over the doors, we're very confident will contain that material within the building structure. The filter socks that we're providing for the aggregate storage, we're comfortable will provide adequate filtration and protection of that material as well. Once again, we're in the headwater, so we anticipate that we will be in backwater, which is essentially flat water. It's not at a high velocity. It's not a lower stream reach or anything along those lines. So we weren't concerned necessarily about velocities. The subsurface sewage disposal system, we agree that system, I believe, was installed in 1981. We did evaluate the system, and we evaluated it with the health district, traded correspondence back and forth, and they agreed that that could be reused. However, I agree with the concern presented by DTC, and we will have that leaching field evaluated by a qualified technician, and that will include a minimum of flooding, and we typically flood those with a dye so that one can evaluate if there's any blowout from the system itself. But we certainly agree, and before we start building anything, that would be something that we would complete. With that said, that concludes my presentation, and we'll certainly be available for any questions that you have.
Thank you, Mr. Brandon. I do have a few questions, clarification, and they're not in any particular order. One thing, you did have David Lord do a wetlands delineation. I forget which drawing it's shown on. And the wetlands that are on the, well, to the north, I think we're familiar with those. That's over the top of that higher elevation. Is that where the septic is actually located? Is that
Yes.
septic located? I don't recall when we did our site visit that we went there, but is the septic above that?
Yes, it's on the high edge, yes.
Okay.
Yeah, there's a pump station that's located right near the scale. So the septic tank is located down here, and then the effluent from the septic tank flows by gravity to a pump station located right on the edge of the scales down near the parking lot. And then that pumps through a pipe up to the leaching field, which is located essentially up above the lower parking area.
Okay.
Yeah.
And in the southern area, the wetlands that were delineated by Mr. Lord are essentially it's sort of like a drainage area that runs along the track. The delineation stopped at the edge of the property. What I think we would appreciate is some assessment of the function and values of the wetlands where that drains underneath.
To the other side of the
To
tracks?
the other side, right,
Okay.
because if there is going to be an impact, it would be helpful to understand what the function and values and what the potential for impact would be downstream. Is that something that you could provide?
Absolutely.
Okay. I think that's also consistent with what DTC was looking for. So you said you will be doing an assessment of the leaching field itself. Do you have a feel for the time when that will be done? Is it a certain time of year when you'd have to do? We have to wait till
Wet
spring?
season.
Wet season. I think we're in, right? So it's something that could be
Sure.
done relatively quickly.
We could certainly do it relatively quickly. We would prefer to do it once we acquire the permits for the parcel. It is a fair expense, but we could certainly accomplish that earlier if the commission felt that it was important to a decision that you'd be making with regard to the application.
I want to go talk about the knee wall for a little bit. Again, I don't recall the plan number that you were showing that. Well, I guess there you could show it.
Yeah.
You could show it on there for the folks, but there was some, what plan sheet is it?
This is
Sheet drawing 3, correct?
drawing 3, sheet 9.
Drawing 3,
Yeah.
okay. Oh, sheet 9. Could you point out where there is not a contiguous knee wall around there? I think there was comment that there is in some area, but it's not in
Yes.
other areas.
Absolutely. So this is a loading dock, existing loading dock, right along here. And the asphalt
Could
in
you
this
also
area is...
show it up top once
Yeah.
you're done? Sorry to make you jump back.
No, not at all, not at all. That's why I'm here.
Thank you.
This is the previous loading dock. It's still a loading dock because the grade outside of it is 4 feet lower than the slab elevation at that particular location. So that is open. And then there's another loading area right over here. That secondary loading area is right here. So those are two areas where we don't have knee wall. There's also intermittent personnel access points where there's a section approximately 3 feet in width where that knee wall is missing as well. We're proposing to actually augment this area with a Jersey barrier system that would give a little bit more height. And actually that allows the operator who's managing that pile to actually push against that Jersey barrier. So there will be a Jersey barrier that will be tacked into the slab that will actually be something that as I say, the loader operator would use to his benefit when filling a bucket.
But I want to make sure I understand, there's no feasibility to be able to totally contain that area. That's not practical.
We could certainly totally contain that. If we totally contained it, then we would essentially have to pick up the drainage from that. Although the drainage right now runs off by sheet flow, we could pick that up, we could channelize it to a particular area.
Could you not run it through the hydrodynamic separator?
Sure. Yep.
Scott, where does sheet flow go now off that area?
I believe the majority of the discharge that I've seen actually flows off from this particular area, flows off at this loading area here. The majority of this area, there are some breaks back here, and there's also the breaks where the loading area is. So that drops there, as well as, I believe there's a couple of spots back here, and this is another point where it discharges.
I guess what we'd be interested in is if you could look at the feasibility of containing that area, similar to what DTC had recommended, and be able to then direct any runoff through some sort of treatment system. You're already proposing that for that part of the property. And I also had a question about the biofilters. I don't have any experience with that sock-like material.
Yeah.
Do you have any information on water quality, where it's been tested, where these have been used for similar types of applications that you could share with us?
Yes, we could pull something together for you with that,
Great.
absolutely.
Thank you.
Yeah.
I'm also interested to hear your overview, if you will, or description of the two deep permits that are required, the Stockpile Stormwater Management Plan. So is that part of what there's a sampling associated with it, there's a number of things you would need to do to comply with that. And then also the general permit for discharge of stormwater associated with industrial activities, if you could talk about both of those.
Yes, absolutely.
Thank you.
So when you stockpile contaminated material, if it is contaminated, once again, we're focusing on asphalt millings and clean materials here. So it would be aggregate, crushed concrete, and asphalt materials. But there is a stockpile, a DEEP permit for maintenance of a stockpile of contaminated material. And there is a variety of different actions that one needs to accomplish. It may include covering the pile. It may not include covering the pile, depending on what type of contaminants you have. In this particular case, we are proposing commodity materials to be stored in that location. So we're not anticipating working under that contaminated stockpile program. The second permit that you referenced is the general permit for the discharge of stormwater associated with industrial activities, and that certainly applies. And in fact, this site is subject to one of the specific sectors. So when they have certain sectors, it means that your operation, and in this case, I believe the sector is refuse activities. They have concern with regard to the potential impacts to stormwater. Now, keep in mind that the majority of the refuse facilities are outdoors. Your dumps and open transfer stations, etc. Ours, once again, is indoors. However, we still have to abide by the same requirements that someone that accomplishes those activities outdoors. And that will include monitoring on a quarterly basis, and there are parameter top limits, action limits, and
I'm sorry to interrupt, monitoring for what?
stormwater quality.
So runoff at following storm events?
Yes, exactly, yeah. And we would, we're actually bound to sample at the discharge points. And we analyze the samples, and then we have certain criteria that we need to actually meet or be below. And if we don't meet or aren't below those criteria, we have to demonstrate to the DEP that we will take certain actions and propose improvements to the site to improve the water quality such that we will get to those criteria. So it's a process that's ongoing and would be applicable completely to this site.
Could you share with us the MCLs for the stormwater?
I don't know them off the top of my
No,
head.
I mean, just at some point, just share
Oh,
what
certainly.
those
Yes, of
parameters are,
course.
what the
Yes.
maximum contaminant levels are.
Yep,
Thank you.
absolutely.
In your flood management plan, I believe I read, or maybe even you said it, that at 13 feet MSL, you were going to have storage for liquids. And I'm very curious as to what liquids. I didn't hear in your description of what you're going to be doing here, mention of liquids. So what is that for?
If when loads come in, you'd be surprised what could be included in a load of construction demolition debris. You can find a variety of different products, including furniture, appliances, etc. A lot of it makes it into the roll-off containers or the trucks that are direct loaded. In certain times, you will find a container of oil, as an example. You're demolishing an old barn or something, and a farmer maintained and kept all of his spent oil. And if it's not properly demolished and not stripped out at the site, that material can wind up coming into this site, at which point it gets separated. And that is the intent of the liquid storage that we have for this site. I believe I included in the application 2 different storage vessels, and I believe one was for oil materials that may be discovered in the demo debris, and the second one was antifreeze. And that would be just a simple drum. It's not certainly a common finding, but can occur. And the DEP needs to be assured through the issuance of their solid waste permit that we have provisions to handle that should it come in. Same thing with batteries. It's another example. We have to have provision for storage and management of batteries, assuming that there may be a battery located within the C&D.
And then that's retained on site for a limited amount of time. There's a certain time limit, you can only keep that.
Correct.
And then it has to be manifested off-site.
Right, and then that material gets stockpiled. Essentially, majority of as I say, the 2 liquid vessels that we have are both, as I recall, 55-gallon drums. Things, for example, batteries, I think we have storage on a pallet for the batteries, so a pallet would be filled. Once a pallet's full, a truck would come and pick those up for recycling.
Thank you. Last question that I had, and then I want to see if the other commissioners have any questions. Then we'll open up to the folks, very patient folks, very well-behaved patient folks. Could you talk about what is the screening process for what comes in? How, when you're going to accept stuff, is there a hazardous material screening process? Just in general, talk about it.
Yes, absolutely. So when one goes to acquire a demolition permit, there's a variety of backup paperwork that you have to provide to the town in order to be issued that particular permit. And initially, an asbestos and hazardous building material assessment has to be completed by a person that is expert in that particular field, usually someone like an industrial hygienist or along those lines. So they run through the building, they identify the hazardous building materials as well as the asbestos materials associated with the structure. And then that report is provided to an asbestos abatement individual or firm. And the abatement firm will come in and remove both the hazardous building materials as well as the asbestos in accordance with all of the applicable requirements by the health department associated with asbestos abatement. And then the consultant comes back in and does a final clearance on that building. And then that final clearance document, along with the utility disconnect documents, are what are provided, as well as you have to identify the location, the destination of your waste. That package is submitted to the town, and then with your license and such, a demolition permit would be issued to that contractor. So that's, as I mentioned, if everything is done properly, all of those materials that I spoke of earlier are out. They're not included, they've already been removed, and they've been essentially cleared by that clearance that we get from that particular inspector.
So is it fair to say, Mr. Andrews, that anything that's coming on site has gone through that process? That it's got a demolition permit, it's been screened on site, there's been abatement done if it was necessary before it even comes to your site?
Absolutely, yeah. Just wanted to check with my associate. Right. A demolition permit wouldn't be issued if all of the hazardous materials have not been documented as removed from the site.
Yeah, Scott's good.
So I noticed your two outlet structures for your proposed stormwater drainage systems don't have outlet protection, they're wrap aprons. Is there a reasoning behind that?
Yeah, they both exist, and they're both on the railroad property. So I'm a little limited on what I can do. Now, what's interesting is that this one right here, in particular, if we talk about that one, which is this one right here, actually discharges right into the ballast. So the wetland that I have delineated across here is actually sediment that accumulated on top of the rail ballast. So that was just a swale of ballast at one time, and sediment contributed and assembled itself there, and now there's wetland vegetation that has come up from that sediment. But underneath that, we've documented that that's all rail ballast, so it's 4 to 6 inch, 3 to 4 inch crushed stone throughout that entire run, all the way down to the end here, where it finally opens up into an actual wetland area. But this particular area here and all the way down is underlain by rail ballast, which is essentially not the size of riprap, but essentially crushed stone for dissipation of energy, etc. This discharge down in this particular location, as I say, it's an existing discharge. It has what it has. We're not proposing to improve that pipe or anything, and we certainly could try to work something out with Amtrak on improving that, but it's not on our property, and we figured it's just a discharge that exists on another property, and we're not proposing to change that pipe at all.
So have you analyzed the outlet velocities, and can you, with your engineering judgment, determine if the outlet protection that's there is capable of handling the flows from your site?
No, we didn't look at either one of them. We didn't analyze either one of those. As I mentioned, both of those were our existing discharges, and we didn't feel that an analysis, we did analyze everything that's on our property, but we didn't feel that an analysis on those existing discharges was necessary. We have inspected them, which was difficult enough to actually get access to go out with the rail and perform an inspection on them. We didn't see any signs of erosion or any concerns, and consequently felt very comfortable that the stabilization that the rail system has provided is adequately functioning.
So you said earlier that you are decreasing the impervious area on your site. So are you decreasing the amount of flow that you're discharging to the wetlands directly from these two outlets?
It's a tiny amount, but yes. Yeah. It's within the error of the analysis that we do, certainly.
I have a question on the two hydrodynamic separators. Do you have a specific unit that you're specifying for this project? And if so, I know from experience that those typically only work well if they have a maintenance schedule and it's kind of adhered to. So how will this kind of be enforced on the owner to kind of keep up with the maintenance schedule to make sure that these are operating as they're specified?
Great question. We go with CDS on this? Contact units. We went with the contact units on this. It's a great question, what you asked. I have found on some communities that I work in and present to where we're proposing something along these lines or proposing some other type of vegetated structure or biofilter, similar concerns. And in the issuance of the permit as a condition of approval, we have had some commissions identify that a maintenance schedule shall be identified and shall be coordinated with the town so that the town could actually audit the site operator to ensure that proper maintenance is being completed on them. And we would certainly offer that up as a condition of approval to the project. I think that's probably the most effective way at ensuring that be accomplished on a regular basis.
Could you or Ms. Pearl just describe the hydrodynamic separator, how it functions, just for the benefit of everyone?
Sure. Yes. Yeah. Uh, Rick just mentioned DEEP would have an interest in that maintenance schedule as well under the permit. So the hydrodynamic separators, they actually have a flow inlet, and there's a variety of different technologies and thought process. Most of them are specific by manufacturer, but essentially what they do is they create a swirling situation within the structure itself that pushes heavier materials out to the outside of where the swirl is occurring, so that that material drops out and settles down to the bottom. And then they have a variety, some have high level and low level plates within them that will pick up that higher level flow and then allow that to discharge. So what it does essentially is it's pushing by it's separating the solids by essentially a swirling process and gravity. So you're pushing it out with momentum to the outside so that it can accumulate slough.
So with those units, since you're in the 100-year flood zone, you're going to expect backflow into your drainage systems. Your outlet is at elevation 2.25. How will that hydrodynamic separator system work with backflow? Are they designed to, allow your system to backflow without discharging those total suspended solids?
Yeah, obviously we're not going to get the optimal swirling when we're in backwater like that. However, we've worked with, I believe, 3 different manufacturers of these, and each one of them under backwater conditions actually retains the sediment within the structure itself. So it's not allowing that sediment to become disrupted and then discharged at that point. That's where I mentioned, I know one of them in particular, they provide some plates, and those plates are how the discharge kind of goes in. And then if there's a backwater condition, those plates actually protect that lower section from being disrupted if a backwater condition comes in. So you can have water essentially could be sitting there, not moving at all. It's specifically during the massive flood event of 100-year, that would certainly be the case. It would be completely underwater, 10 feet of water.
I had a question on your filter socks that you're using for your outside stockpile area. Can you explain what they're made up of, what is inside them, and how long you expect them to last? And again, sort of like the hydrodynamic separator, is there a maintenance schedule for replacing those and noticing them when they're no longer performing?
Yes, absolutely. Great question. So the material that we fill those with, you can fill it with a variety of things. Wood chips, some people refer to it as mulch. I prefer the compost-filled filter socks. And the reason is that the compost-filled socks, that's the same material that we use typically for biofilters, in-ground biofilters. And those are proven. They're proven effective in treating stormwater. So we're proposing to use compost-filled filter socks. And you can buy these socks, you can actually order the socks specific to what your use and need is. For example, if you're on a construction site and you anticipate to be constructing over a 6-month period, and you want the logs or socks to disintegrate at the end of that 6 months, you can actually buy a fabric that's UV protected to a 6-month lifespan. At the end of the 6 months, that fabric disintegrates, and the mulch just turns into the woods at which it would be placed. What we're looking for is a much more robust sheathing on the outside, and we would propose utilizing either a woven or non-woven geotextile rather than and that would be UV protected, and we are anticipating a minimum of 365 days life cycle out of those, at which time those would be removed, both of them, and then replaced with new. And I know we've been involved in the design of several biofilter systems, and we typically manage those biofilter systems every 5 years, where we hog out the compost material, usually a composted sand mixture. We'll hog that material out every 5 years. So I think doing this annually, as we put together in the plan, is really going to enhance the quality of the stormwater, as well as ensure the longevity of those systems, because I know we can get to 365 days. In fact, I'm on 3 years on a site right now where they've effectively stood up for just a bit over 3 years.
How are those going to be anchored to the concrete pad? Are they just their own weight?
Yes, exactly, yeah. As I mentioned, sometimes in the biofilter system, we'll mix sand in with the compost. Sometimes with the filter socks, we'll mix sand in with the compost as well to provide a little bit of added weight. But they don't float up, that's for sure.
So
They're very, very, very heavy once they get wet.
So during the 100-year flood, you're not expecting these to kind of float away and...
That's correct.
Okay. Just out of my own curiosity, have you gone for any other permits, either through DEEP or the Army Corps? And if so, what were those permits?
Yeah, we're not proposing any activities within any of the wetlands, so we're not subjected to the Corps. We are in front of the DEEP with a permit, a solid waste permit application. That's an individual permit application. And we have been in front of the, as I mentioned earlier, the Zoning Board of Appeals from town for the site, as well as the Design Review Board. And that's where we stand at this particular point.
So no permit with DEP as far as wetlands is concerned?
Correct. We envision our solid waste permit is about 2 months out. We just had a meeting with them recently, and we envision acquisition of that permit within the next couple of months.
Bert, you got any questions? Sure. Eddie?
I just had a question I just got a question if the electricity was on lots, how would the pumps work? You have a backup 3 pumps?
For the sanitary?
Yeah. Because you were saying that you use a lot of pumps here, pumps there. If the power grid goes down, like it has in parts of our town for 3, 4, 5 days, is that going to affect the water or the wetlands?
No, not at all. We're not proposing to pump any stormwater on the site at all. The only pumping that we're proposing is of the effluent, the septic tank effluent, and that will actually be pumped up to the leaching field, which is up above the grade that we're proposing to perform the activities at. But other than that, we're not proposing to pump any stormwater on the site or anything.
How would you pump the septic up with no electricity? Do you have a backup plan?
No, not at all. If we didn't have power at the facility, we wouldn't be weighing trucks and such, so we would have to wait until such time as power was restored, or we hooked up a generator so that we'd be able to run the facilities. There's also some OSHA requirements associated with operation within the building, and those facilities would need to be up and running for us to be operational at that point. So during a power outage, unless we were able to get a generator and actually bring a variety of the facilities up to power, we'd have to shut the facility down temporarily.
Andrea, do you have any? You're good. Do our student members have any questions? You're all set? All right. Of course, Eric, I'm sorry. Yeah.
Did you have David Lord evaluate your application for impacts on the wetlands? Or did you have any soil scientists do so?
No, David flagged the wetlands and gave us the wetland report, and then we built everything essentially from there.
Okay. Do you have testimony regarding impacts on the wetlands?
I indicated, I believe throughout my presentation, that we're actually improving the water quality with the application. We're proposing the installation of a couple of different improvements to the site, and we certainly will be improving the water quality discharge.
Okay, there's no expert testimony on your behalf that someone has evaluated your application and finds that there's no impact on the wetlands?
Correct.
Okay, fair enough.
I believe earlier you did indicate that you would have functional values done on the wetlands, both on and off site. And as part of that, I think maybe I wasn't clear, we'd like to know a professional opinion on the potential for impact from the site, the proposed site activities.
Right, from
Okay.
a soil scientist or a biologist.
Yeah, wetland scientist.
Yeah,
or
wetland.
Exactly,
Absolutely.
thank you.
Yep, absolutely.
So I think that will be coming here. Is there anything else? We're good? Okay. At this time, we will move into the public comment. Do we have a sheet somewhere?